Hey guys, and welcome to the 7th video in our Pygame RPG series. Here in this video, we're going to take a look at a lot of small improvements like performance, font, text, rendering to the screen, player wrapping, and some other useful things like platforms. Okay, well, that's something really interesting that I want to show you guys. So yeah, before we actually begin though, this is something I want to say. If you guys have been following the series from the start, then that's a really good job. Okay, most people don't really have it in them to actually follow such a long series, and I'm sure many people have already dropped this, as they do with any other series like this. But if you guys have been following up so far, then that's really great to hear, and I hope you guys continue watching because there's going to be a lot more content coming up. And on the same note, I hope you guys subscribe to the channel. Okay, and most importantly, leave your feedback down in the comment section below. Okay, because I'll be dividing the game into parts. Okay, like we'll complete part 1 in a few videos, then I'll sort of just take a break, and then I'll take in your feedback and then maybe adjust what I have planned for part 2 based on that. Okay, so if you guys have something interesting in mind, I could include that in the next part. Okay, so with that, let's begin. Okay, so the first thing I want to take a look at is performance and FPS. And this is because, as you might already know, that we were facing some performance issues in the last few videos, especially in the last one, ever since we began adding in more entities and lots of animations and stuff. So we'll take a look at FPS and performance first. And because I want to basically improve our performance, I want a way for us to actually observe how our performance is improving. So for that, we'll make an FPS counter. And for that, we're going to make a user interface class. And of course, we'll need this class later on as well, because we'll be adding an UI later. Not now, of course. A UI is something you usually add after you make the main game concepts. Or at least that's how I do things. So I'll open up this file here, import Pygame, make the user interface class, okay? And let's try to move it fast, okay? Because I want to cover lots of stuff in this tutorial. I don't see the need to inherit from pygame.sprite, so we'll leave that for now, okay? And we'll make a new function here called render. Okay, I'm just setting up the functions now. Okay, I'll leave both these empty for now though, because I want to actually begin setting up some other stuff. Okay, I want to set up some colors and fonts. I'll make this thing called color red, and then I'll use the RGB values. Basically, this is just a tuple. Okay, it's just a tuple for RGB values: red, green, and blue. Okay, just max it out if you want the color. Okay. You can use a combination of colors over here, a combination of RGB values to get different colors. And if there's some color in particular that you want, just Google it, find out its RGB value, and just insert it over here. Okay, that's all. So let's continue. Green, okay, it's going to be 02550. Color blue is going to be 00255. Okay. Next up are some fonts. I'll make small font, okay, regular font, and large font. Okay, I'm gonna make 3 types. Do you make them in a very simple manner? Pygame.font.sysfont for system fonts. And by the way, I'll include a link for a video on fonts and stuff as well, if you guys are interested in learning more about this. But I'll be using for this video just a very simple Verdana, and I'll put the size for the small font 10. Okay. And for the large font, regular font can be 20, and large font can be 40 for like headings and stuff, I guess. And let's increase this a bit to 12. I think 10 is a bit too small. Okay, so just one thing I want to tell you guys. What we did here, we didn't exactly create text. Okay, we just created fonts, fonts in a Pygame format. Okay, we can now use these fonts to create text. Okay, and let's create some text down here. Or actually, before that, let's begin creating some other stuff. Okay, what do I do in the init function? Actually, maybe I should have just done this. Maybe I should put them in here. Maybe that'll be a better approach. So let's go ahead and do that. Okay, but then I'll need to add self over there, self over there, self over there too, self over there too, and over there. Okay, great. Now what I want to do is actually make a function maybe for the status bar. Okay, the status bar is where we will display the FPS. How do I do this now? Well, what I want to do is create a black rectangle or something upon which we can write the text, okay? Some kind of menu bar. And maybe later on, if we want to get fancy, we can add in some kind of images for our menu. But for now, or you know what, let's just keep it simple. I'll call this text text just for now, okay? Later on, when we add more text, we'll change things up a bit. Then I'll say regular font dot render, and let me just make that self.text, okay? Render, then this takes 3 parameters, okay? Render takes 3 parameters. The first parameter is the text that you want to get printed out, okay? Now this is going to be a little confusing because we need to over here update the FPS, right? So I'm going to need the FPS value, and how am I going to get that? Okay, I think I got it. Okay, just bear with me for a while. Draw FPS. Okay, and over here I'll write in self.text 0, and the other parameter just leave it at true, and the third parameter is the text color. Okay, so let's make some more colors. I want to make one for white, and white should be devoid of color, right? And let's make black. So for black, all RGB values are at their max. At least I'm pretty sure. Maybe I got this the other way around, but we'll find out soon enough. So color black, okay? And this will render our text, okay? Now down here, I'm going to say, we'll take display over here, our display surface, and then we'll display it, okay? This basically renders a drawable text, okay? This renders drawable text. This does not draw it to the screen, okay? We still need to draw it. So for this I'm going to do self.text. And I almost forgot, this is actually going to take some position, right? Where do we want to draw this? So maybe something like 700 on the X and 100 on the Y. And on second thoughts, let's change this to update, okay? Because later on, we'll actually be adding a lot of stuff that needs to be updated. Like maybe something like our current level, or maybe something like our current mana points or something. So we can use the status bar for a lot of stuff. And in the update function, we can pass in from the game file a lot of useful stuff, like FPS, which we need. So over here I'll do convert to string FPS and then render it again as self.text, okay? And then draw that over here. So I hope you understood all this. It wasn't too complicated, I hope. It's mostly just simple stuff, okay? UI is just long, a little boring, but it's simple enough, okay? And most importantly, remember to keep your UI clean, okay? Otherwise it just becomes a massive pain later. From user interface, import user interface. Come down here then, and let's try this cleaning things up a bit, okay? And I'll make the UI over here, UI for short, user interface, okay? Come down here, let's try clean things up a bit. Render functions, okay? Render functions are over here, and the update functions are over here. Update functions. And later on we'll combine these two enemy functions into one, okay? When we next work on the enemy. So for UI.update, and this needs the FPS, okay? How do we get the current FPS? Well, we use the clock. We use the get FPS function on it, and voila, we get the FPS. That's all it takes. And the clock is what we made earlier, okay? That FPS clock, remember that. So I think we're done here. Let's run this now. Okay, an error. I think I know the problem. I think we need to do this in small font, not capital. Okay, now let's go back and run this. Okay, one more error. Regular font dot render is not defined. Okay, I think I know what's wrong here too. It's self.regular font. Okay. Let's run this again. Okay, and things are running, but I do not see any font here. So what's the problem? Oh, well, I didn't even render this. Okay, render and display. Let's run this now. And there's our FPS over there, and you can see at certain points it's really lagging. Okay, that's because of my hard drive, actually. I believe it's pretty slow, and then coupled with the screen recorder, it kind of sucks sometimes. So yeah, as you can see, the collision detection is working perfectly fine though, so that's something. Yep, if I don't attack him, then player was hit will get printed out. At any rate, let's fix this FPS now. And more interestingly, I was actually right. I actually did flip them. So let's do that. Okay. And black, actually, now that I think of it, is when there's no color, and white is basically all the colors combined, right? So yeah. And let's position this a bit higher. Okay. And let's just run this one more time. Okay, we can see the FPS much more clearly now. Good. Now let's come up here and actually begin putting in those optimizations. The reason I'm not focusing too much on the optimizations is because they're really short and they'll happen really quick. Watch. Convert alpha. This is the magic function. This is the magic function that can like take your FPS from like 100 something to like 500. And this is, by the way, something that I'm talking about from experience. Okay, when I did this on the game initially. Okay, so convert alpha. What does this do? Well, let me explain. Let me just put all these in first. Well, you see, when you take an image and load it in, like we have over here, and when you want to draw it, okay, to the screen, like we keep doing, then what happens is a conversion is necessary. This conversion is necessary because it needs to be in a Pygame understandable format, basically. Okay, it needs to be drawn in a specific format. So the thing is, every time you draw something, every time you draw a frame in Pygame, this conversion happens. And this conversion, the problem is this conversion is slow, okay? Because it's a, if I remember correctly, it's a pixel by pixel conversion. So it takes a lot of time to execute. So what the solution is that we use convert alpha right in the start when we actually load in these images, so that they basically get converted from the start. If we do this, we don't have to convert it while it's being drawn. Okay, it doesn't need that conversion. We can basically skip a massive step. We can skip a massive, bottleneck that basically prevents our Pygame, game from reaching its full potential. Okay, this change alone is massive, and this is pretty much the only change that we're going to be covering right now. There are a few more things, and there's some things with the audio as well, which I'll cover later. There's actually one more minor thing I want to show you guys though. Come over here to our game loop and change this from true to 1. Now that was actually a performance optimization. It's barely anything, it's a very minimal thing, but it's actually an optimization. The reason is because Python needs to convert from true to 1, basically. Writing 1 instead of true actually saves you an operation. So this is kind of nice, I guess. It's a small optimization, but whatever. Make sure everything's okay. Okay, and we have everything set up over here. Great. And let's run our code now. Okay, what's this? Cannot convert without Pygame.display initialized. Okay, I think this problem is actually happening because a player is trying to convert alpha and everything, and the problem is over here is that the display is being initialized down here. So here's an idea. Let's go over here and create a separate function, okay, right at the bottom, called load images, load animations. Okay, that sounds better. And then let's take all of these and copy paste them in here. Now, this is kind of ridiculous, honestly, but and we'll need to go around doing self everywhere now. Self over there. I can only imagine the amount of times I'm gonna forget adding this. Okay, where else do we need to add this? Where else do we need to add this? Self over there. Self over there. Where else? self over here, self over here too, over here too. And I think that's it. Okay, good. So, and then over here I'm going to call, after the display is initialized, I'll call the player dot, hold on, where's the player? Yeah, player's here, right? So I'll do player dot load animations. Okay, cool, right? So this should work out pretty well. And yeah, there we go. Okay, so looking at it, I can still see a minor slowdown every now and then, like that. But I think it's going actually better now. Okay. I guess it's just my laptop's fate to be like this, but things are better now. Things are bearable now. Okay, good. So let's, without further ado, let's get into some of the other stuff that I want to show you guys. Okay. The first thing is with the player. I want to show you guys something kind of cool. Okay, just watch and observe carefully. If self.pause.x is okay, if it's greater than the width, which is 800, self.pause.x is equal to 0. And L, if self.pause.x is less than 0, then self.pause.x is equal to 800. Well, I think I did that right. I mean, I hope so. Let me go back and try running this code to see if I was actually able to do it properly. Well, yeah, kind of. It's a bit finicky, but yeah. Okay, one thing, I really need to disable these prompts over here. These are pretty useful, okay, while we were doing the collision detection, but we should really just turn them off by this point. So I'll just go into, we had them in the enemy, right? So let's go to the enemy and just disable these, honestly. We'll re-enable them later once they're necessary, okay? Because we'll continue the collision detection and all our talk about that later. Okay, so back into the game. Great. Okay, so let's try that warping again. Okay, great. Okay, let me fix a slight issue that's being caused over here. We just need to tweak the boundaries a bit, okay? And by now you've obviously understood what I'm doing here. I'm just adding in player warping, okay? So you can go out from one end and end up at the other, okay? It's just kind of cool. So I'm just adding it. And if it's less than 20, minus 20, or you know what, minus 30. Okay, so this should be working perfectly now. Okay, so slow-mo, huh? Okay, so yeah, pretty good. Okay, now for the last feature that I want to add here, and let's move quickly with this again, hopefully. I want to basically add in extra platforms for the ground, okay? I'm going to go here, open up our ground file, and we need to make some adjustments. First of all, we need to change a few things. Basically what I want to do here is make additional platforms, okay? Like in those old Mario games, platforms and stuff. I want to create those. So I need to make some modifications over here, first of all. First of all, the rect should, first of all, I need to resize the image, okay? So for this, I'll do self.image is equal to pygame.transform.scale, and this takes self.image, and then over here it takes a tuple, okay, for the value, for the resolution that you want to resize it to. Okay, so we'll just use width and height, okay, which we pass in over here, and this is the reason I actually passed in width and height in preparation for this moment, okay, because I want to create additional platforms, even if we're not going to use them later on. I just think it's good. We'll probably use them for level design later on, hopefully. So yeah. And over here, soft.rect, okay, that gets rect. And what else do we need to do? Honestly, I'm not sure. So, you know what? Let's just try running it the way it currently is. Let's go and make a new ground object. Okay, just over here. Ground2 is equal to ground. And what's the size that we want to keep? 100, okay, in the width, and 20 on the y. and the position can be somewhere in the middle of the screen, 300 on the X, 200 on the Y, and of course the same image gets passed down. Of course, if you want to use something different, like if you want some variety in your ground objects, go ahead. Okay, ground group dot add ground 2. Okay, well, let's add this in here. And you know what? We're going to use something a lot better. Instead of doing ground.render each time, you know what I'm going to do? I'm going to do for grounds in ground group grounds.render. And now no matter how many ground objects we have in the ground group, this is just a simple 2-line way of calling the render function on all of them. Okay, this is much more efficient, and this is basically a very big benefit of having ground groups. Okay, of having groups in general, I mean. Okay, that is massive. What just happened here? Okay, and this is a bit disturbing. Now let me go back here to our ground file. Did I save this? I don't think I saved it. Because I'm kind of wondering. I did resize the image. Oh, there we are. Okay, this is just awesome. I don't know about you, but I find this really awesome, and I really wish it would stop lagging. One day I'll record this on my PC and then send a video over here. Okay, just so that we see this without slowdowns. So yeah, that's pretty cool. Let's go ahead and make 1 or 2 more, because this is the last thing we're adding. So it's just let's play around a bit. Ground 3, ground 4. Okay, and let's change the size of this one a bit. Maybe make this one a bit longer. Let's place this one somewhere in the start, this one somewhere near the end. Okay, let's change up their Y positions a bit. Okay, and let's add them into the ground group now, and let's run. Okay, see, this is just awesome personally, and because we've implemented gravity into the enemy as well, the enemy will also be able to navigate on these as well. Now, of course, he can't jump up there. He doesn't have the brains to do that, but we can. So yeah, pretty cool. Okay, so this was really great, I think, and I had a good time making this, and I really hope you guys enjoyed some of the stuff here, especially the ground stuff over here and those performance optimizations. Okay, you'll really need them, trust me. The image one, the convert alpha one. Okay, one thing I forgot to mention, convert alpha and convert. These are actually both options. Okay, you can use convert alpha and you can use convert as well. But convert alpha, the reason I'm using convert alpha is because if you use just convert like this, then it doesn't take into account the transparency. So use convert alpha, okay? Most of the time. You'll almost never need convert. You know. So yeah, this is really useful, and just because you can't notice it much in my video right now, that doesn't mean that it's not actually improving the performance. And the reason behind this is because I believe the reason I'm slowing down is because of my hard drive, not my CPU. So that's kind of the thing. In another test of mine where I actually checked this out properly, I uncapped the frame rate, okay, and without this optimization, I was getting 100 to 150 FPS. With this optimization, I was getting around 500 to 600 FPS. So that alone should tell you just how useful this optimization is. Okay, so I hope you guys enjoyed this video. I hope you guys subscribe to the channel and leave a like, leave a comment, leave some feedback. I hope you guys enjoyed this and are eager to see more. So that's it for now, and I'll see you guys in the next video.